The El Nino Southern Oscillation event of 1997-1998. In early 1997, the trade winds in the western and central equatorial Pacific began to weaken and reverse at a significant rate. The loss of the trade winds caused the western Pacific warm pool to drift east and prevent the equatorial cold tongue from developing. The cold tongue is a band of cool water that is a result of equatorial upwelling typically occurring in the eastern and central Pacific. The sea surface temperatures were rising so rapidly from June to December 1997 that anomalies were averaging a record of 4 degrees Celsius in the cold tongue region. Westerly winds that originated from a Madden-Julian oscillation over the warm Indian Ocean added to the rapid development of the ENSO, as MJOs are typically found over warm surface water. The increase in the area of the warm pool created more opportunity for MJOs to form, which created a positive feedback that increased the warm pool expansion as westerly winds were being forced by the MJO. The global impacts of the 1997-98 ENSO event were typical and well predicted throughout the season. Southern Africa, Southern Asia, the Philippines, Australia, Central America, and northern eastern Brazil all experienced warmer and drier climates. China, Peru, and Ecuador experienced a warmer but wetter climate, and the southeastern United States had a cooler and wetter climate. It was the second warmest and seventh wettest winter since 1895 for the United States. There was flooding in the southeast, ice storms in the northeast, flooding in California, tornadoes in Florida, a wetter winter in the south, and a warmer winter in the north. The 97-98 El Nino event was also an opportunity for the Tropical Ocean Global Atmosphere Program, also known as TOGA, to show off its newly developed ocean observing system. The TOGA program recognized the value in being able to predict ENSO events and focused on getting real-time measurements of surface winds, sea surface temperature, subsurface temperature, sea level, and ocean velocity. This newly developed ocean observing system was made up of observational programs such as moored buoys throughout the Pacific, surface drifting buoys, and an island coastal tide gauge network that was coupled with a satellite network that measured surface winds, sea surface temperatures, and sea levels. This new system was able to make early predictions of more storms and precipitation for the south and far west. This prompted the Federal Emergency Management Agency to issue warnings and promote mitigation actions. This made national news and was perceived by the nation to be a bad thing, as there was anticipation of flooding and bad weather. These early warnings and preparations likely saved lives and money. There were many societal and economical impacts as well. 35 per 1,000 people are affected by natural disasters worldwide during an ENSO year. That's over 4 times more than during non-ENSO years. There is a correlation between ENSO events and an increase in the populations of mosquitoes and rodents, and thus an increase in disease that those animals carry. A study done by the American Meteorological Society on the impacts of the 97-98 ENSO-generated weather in the United States found that overall the population benefited. Although 189 lives were lost, mostly to tornadoes, it was estimated that 850 lives were saved due to the mild winters in the north. And while direct economic losses were estimated to be $4 billion, benefits were estimated to be $19 billion. The positive net economic effect was due to less need for economic relief, the reduction in expenses such as natural gas, lack of spring flood damages in the north, and no major Atlantic hurricanes.